Hi, I'm Sean.
And I'm Dale, and we're going to be looking at an example where we move form elements out of the way of the keyboard when the keyboard appears.
Exactly. So let's go to the main storyboard and let's expand our document outline because we're going to add a scroll view. And we're going to have the scroll view be our root view controller. So instead of having a view, let's just delete that. And let's go down here in our object library and search for scroll view.
So our solution to the problem of how you get the form elements to move is by placing the form inside of a scroll view.
Exactly. So now that we did that, that's our root view. Let's add a regular view on top of it.
You mean on top or inside of it?
Inside of it.
Okay.
Appears to be on top, it's actually going to be inside of it.
And we can see that in the navigator. Scroll view contains now a view.
Exactly. So I'm going to add a couple constraints to this. I'm going to pin it to all four sides. And then I am going to set the width and the height.
And what this is going to do is create a view in the scroll view whose size is the visible area of the scroll view, and will tell the scroll view that its content size, the size inside, is also the same size.
Exactly.
And in a way, this may seem a little counterintuitive here at first because you're thinking, well, the view inside the scroll view isn't going to scroll because it's exactly the size of the scroll view. What we are going to do when it comes time to move the form elements is to do an inset, which will tell the scroll view that its contents are bigger than they really are, giving us enough room for it to be able to be scrolled vertically to get the form elements out of the way of the keyboard.
Exactly. So I pinned the view to all sides of the scroll view. So what I'm going to do now is over in the document outline, I'm going to control click from view to scroll view, and I'm going to select equal widths and equal heights. So now we've set both the constraints of our view as well as the content sizes for the scroll view. And notice how it's not complaining anymore that I don't have enough constraints. So now we could treat this view just like we would have a regular view. We could add text fields to it. And let's do just that. I'm going to add a text field to the very center. And I'm going to center that vertically and do leading space to container. And let's get rid of that delta on that leading space real quick. And I'm going to add a trailing space to container as well. And I'm going to get rid of that delta as well. And notice how this time, though, it goes all the way to the sides. We don't necessarily want that. So let's set it in about, well, let's do 20. And let's do the same for leading space. And now we have it a little bit inset from the sides. And I'm going to go down here to resolve auto layout issues and update frames for the selected view. Now I'm going to add another text field to it. I'm going to add this one. Normally it would be 8 points down from that text field, and we'll start off like that, but then we're going to change that delta a little exaggerated so we can see the behavior of the scroll view. And let's get rid of those deltas as well for the left and right constraints. And let's modify this top space from 8 points to 40. 60. So now the keyboard should pop up and appear over this bottom text field, and our entire UI needs to scroll to accommodate that behavior.
And while we're here, could we give those text fields some placeholder text so when we're talking about them, we know which one we're talking about? So yeah, that one's 1, and the second one 2.
Okay. And let's see the problem before we implement any of our code. Let's actually build and run this and witness it firsthand, the problem itself. So we have our first text field. So I'm going to build and run this and we can see our problem firsthand. So I'm going to select the first text field. And notice what happens the second that I do that. The second text field has now disappeared. The user can no longer tap it. When I rotate it, now even the first text field's gone. Mind you, on a bigger device, maybe it would be seen, maybe it won't. And if we dismiss the keyboard using the button that the 6 and the 6 Plus have on the horizontal landscape mode, it comes back. But that's not necessarily the case. So what we're going to do is we're going to have to scroll our view up every single time a text field underneath the keyboard is tapped. So I already have the code copied over, translated, and slightly modified from Apple's documentation online. It was in Objective-C, now it's in Swift, and as well as updated to accommodate newer iOS updates. So let's tie it together. So first, we need to access the scroll view, or our root view, and to do that, we need the document outline. So I'm going to expand the hierarchy until we get to our scroll view. And I'm going to control click from our scroll view to our existing IB outlet that already exists. Release. Perfect. It highlights the entire scroll view.
And yes, we do realize we could get to that through the view of our view controller, but this obviates that we are dealing with the scroll view. Also, you might have a situation where the scroll view is in fact not the root view, so we figured it'd be best to illustrate this by having an IB outlet to the scroll view.
Exactly. So I'm also going to add a tap gesture while we're here to the view itself to get rid of the keyboard that way. I'm just going to release that on the view, and I'm going to control click from the tap gesture recognizer that appeared at the top to our IB action called dismiss keyboard. And we also need to set the text field delegates to ourself in our UI by going up, control clicking from our first text field to view controller and selecting delegate under the outlets, and doing the same with the second text field.
So let's explain a bit about what we've just accomplished up to this point. The code is already in place for making the view controller a UI text field delegate. We need that because we need to get access to text field did begin editing and text field did end editing. We're going to use that to know what the active text field is. And we also have tied in a tap gesture to the dismiss keyboard, which takes the active text field and calls resign first responder in order to make the keyboard go away when we tap outside of the text fields on the view in general. We also have here text field should return. So if the user taps in a text field, enters some text, and taps on the return key, that will also take the active text field and resign first responder. Note that none of this at this point yet actually deals with moving the form so that the text fields are visible when the keyboard appears. This is just set up so we know what the active text field is, and we're also dealing with making the keyboard go away when certain gestures and actions happen.
So let's start going line by line through it and talk about the new code that we've added. So this NS Notification Center defaults in our add observer. We're adding a notification to respond to an event. How would you explain that, Dale?
So we deal with events through things like IB action. So if we look here at dismiss keyboard, that's an IB action, which we could have tied to a button or we have tied to a gesture. So that's kind of one kind of event. We are also dealing with events in this example through the delegate methods. Text field did begin editing, did end editing, should return, are all based on being called when events occur. We now have yet another way that we are able to detect an event and have some code called when it occurs. We can add an observer through the default center of NS Notification Center on particular events. The one that is of interest here is the UI keyboard did show notification. This occurs when the keyboard did show. The selector is the method that we want called when that event occurs. Keyboard was shown is right here. So the string that is provided here as the selector is the name of the function. And then the colon is an indicator that that function receives parameters. So the fact that this receives an NS notification object means that the colon needs to be present. If we were dealing with selector that had no parameter list, then the colon would not be there.
So we're handling when the keyboard was shown, but we're not handling for when the keyboard was hidden. So let's add another observer in our view.did_load to handle that behavior. To do that, it's ns notification center dot default center dot add observer. Our observer is going to be self. Our selector will be keyboard will be hidden. And notice how it takes a parameter, this a notification, ns notification, meaning that we have to have a colon after it. Then the name of the notification is called UI keyboard. And notice how I'm starting to type, and I just love auto-completion just for this reason. Keyboard. And then we want did hide notification. Or actually, let's do will hide in this case, meaning that it's going to get called before the keyboard disappears. And then our object, we don't need to pass anything through. Let's just give it a nil. So we just added another observer. So essentially this method down here will be called right before the keyboard will disappear. So let's go through some of the code. So we have our text field delegates for text field did begin editing, text field did end editing to track the active text field. We have text field should return to handle when the user taps return. We have dismiss keyboard to handle when the user taps to dismiss the keyboard on the view. And here we go. We have keyboard was shown, a notification, which is of type NS notification. This parameter is passed in through the NS notification center. And our first line, let user info equal a notification dot user info. And if we look at this, user info is a dictionary of type NS object, any object. So what we're going to use that for...
And by the way, it's an optional.
And it's an optional, exactly.
Which is why on the next line you say if let info equal user info.
Exactly. So we have to unwrap that optional, and we're going to use that as an info. So now info is a dictionary of type NS object, any object. So info actually holds the size of your keyboard that called that notification. And that's exactly what we want. We want to know how large the keyboard is so we know how much to push our view up, essentially, above the keyboard.
And I'm really happy you're supplying that line of code. I can look at this line of code and use it. I'm not sure that I would have been able to come up with that line of code because you're taking that dictionary element and you're actually casting it as an NS value.
As of recently, that is now required. Previously, you could have normally just casted info, UI keyboard frame begin user info key as a CG rec outright. As of in Swift, that's no longer the case because it's type safe. So we're going to need to cast it as an NS value, and then NS value has a method to retrieve a CG rec value out of it. And we only need the size of the rec. We don't need all the coordinates or anything out of that. We just need the CG size.
And the only particular part of the size that is important to us is the height of the keyboard.
Exactly.
The scrolling that's going to occur is going to be in the vertical, and we need to know how much we need to enable the ability to scroll in the vertical.
Exactly. And I'm saving this under a constant called keyboard size or KB size. Our next line, let content insets equal UI edge insets make 0000 KB size dot height 00.
Now, click on that method. Notice that is a top, left, bottom, and right value. And I think the easiest way to visualize what an edge inset is either a margin or padding. It's additional space around the content. So we're going to take what is inside the scroll view, which happens to be our view that has our 4-minute, and we're going to add an inset on the bottom that is the height of the keyboard, meaning that the apparent content of the scroll view will get larger by that height.
Exactly. And we're saving that under a constant called content insets. And then on our next line, scroll view. So we're accessing our root view in this case. It's scroll view. And we're setting the content insets equal to the content insets that we just created. There's a catch though. Even though we did that, The scroll indicator on the side saying where you are on your view doesn't change. So we also need to set the content insets for that equal to the content insets that we just created.
And I find this fascinating, and one should pay attention to this detail. On scroll view, it's .content inset. On scroll view scroll indicator, it's insets. And then, of course, you named your variable content or your constant content insets because you used UI edge insets make. Wow.
Yep. So that essentially pushes up our view above the keyboard and allows the user to then scroll. Scroll views now have an innate ability to move it up specifically to the text field visible. And we'll see that in behavior soon enough.
But that can't happen unless there is room for the scroll to occur.
Exactly. But now that we scrolled, let's say the keyboard is dismissed. We now need to essentially reset everything to the state of not being able to move. And we do that using the method that we registered with this notification up here, keyboard will be hidden. And we essentially set the scroll view content insets to 0. And we set the scroll indicator insets to 0 by using UI edge inset 0. And that's the same thing as saying UI edge insets make and just passing 0.0 as all four parameters. So now when I build and run this, and I click the text field 2, remember how the keyboard appeared over it last time. Notice how it scrolls up to it. Now I could even scroll, and I could get access to all the elements of the view by just scrolling on that. And now say I want to dismiss the keyboard, I'm going to click return in this case. It moves everything down. I can no longer have the ability to scroll around. Let's click 2 again, scrolling, and I'm going to tap the view. Everything disappears.
So let's click on 2 and then click on 1 and then click back on 2 again. Just want to see if there's any movement. So there's no movement because the keyboard already has given us the inset and we have the space up that we need. But something kind of doesn't feel quite right to me. That second text field sits literally right on top of the keyboard. And you mentioned this is the default behavior?
This is the default behavior of scroll views.
So is there a way we can introduce a gap or a space in there?
There is. And so let's go back to our code to keyboard was shown. And let's add these 2 lines of code. And we also have to add a constant to the top of the amount of padding that we want to add between our keyboard and the active text field. And I'm going to go to the very top to do that. And let's just set that to 10.
And is that, I believe that's a CG float, is it not?
That should be a CG float. You are correct. And now let's look at the 2 lines or 2 sections that I just added. I added let active text field size, and I created a CG rec. And then we have this. But let's talk about that CG rec real quick. I am getting the active text field's X position and the active text field's Y position. I'm getting the active text field's width, and this is the key. I'm getting the active text field's height and adding the vertical spacing to that. So it essentially treats the active text field height plus that constant to make that rec.
So the next little block of code points to why we're creating this rec to try and make some sense of why we're creating the rec and why you're adding that vertical spacing. Scroll rec to visible is a method on the scroll view to say to the scroll view, we want to take this rectangle and move it to a place where it can be seen by the user. So if we define a rectangular area, the scroll view will try to make that rectangular area be something that can be seen. By making the rectangle not just the size of the text field, but the size of the text field plus some additional height, we're getting the scroll view to do the work for us of scrolling to enable that. And that a little additional space will appear as a gap between the text field and the keyboard.
Exactly. And notice the second parameter that we pass into that scroll rect to visible is animated, and we set that to true. We don't want it to appear jerky to the user. We don't want it just to happen. We want it to be slightly animated, so we pass in true through that. But then let's talk about this dispatch underscore async dispatch get main queue, and then we pass in this closure. Dale and I discovered that there's two methods that you could do here. You could have a timer set to 0 seconds and execute the code then, or you could use this closure block essentially to have this code activate on the main queue.
So what we believe is happening is if we were to try to scroll rect to visible inline in the code here, that we are doing so timing-wise either before iOS has a chance to do its own scrolling and then we're kind of overriding it or being overridden by them, or there's some locking condition where we are setting something and the system is setting something. And basically, if we don't dispatch async or call a timer to execute this code later, it won't occur.
Exactly.
I mean, the code executes, but we simply don't see the scrolling to the position that we want. By either doing the dispatch async or the timer, we're delaying the execution of this code to a later time, which I think gives iOS a chance to put things the way it wants and then have our code execute.
Exactly. So now let's build and run this, and let's see what happens. So when the user taps to the second text field, notice how it scrolled up, and notice how there's now this padding in between the keyboard and that text field. So let's access the first text field, scroll up a little bit, let's say right there. Now I access it, and notice that it doesn't do it that time.
And that's because we're only telling the scroll view to scroll rect to visible inside keyboard was shown. But at the point that you're going to the next text field, the keyboard already is showing.
Exactly.
So I figure we have two options, one that I don't particularly care for and the one that we're going to implement. I suppose as we move from one text field to another, we could make the keyboard go away.
Right.
And then make the keyboard come back again. Or we could execute the code to scroll rect to visible when we know we're switching from one text field to another.
Exactly. So I'm going to take the exact two sections of code that I typed down there, and I'm going to type it up again in did begin editing. So now when I build and run this, let's select the first one this time. Let's drag it out so 2 is visible. There it goes. It just scrolled. So it will always have the padding no matter where you are. It will ensure that there's padding between the text field and the keyboard.